While most of the unit focuses on linear equations, you may run into a system of equations that's not linear, like this one. In this case, we've got a parabola and a line, and they intersect in 2 points. So if you were to solve this system, you could use substitution or elimination. You would end up with 2 solutions exactly, because that's how many times they cross over each other. This is more typical for the unit. You're going to have a lot of problems just like this. You've already been solving these, so I'm not going to go all the way through the process. If you run into a system of only 2 equations that has 3 variables, we're not going to just stop and say no solution. We're actually going to rearrange these equations so that they're more meaningful. This is a dependent system because there's actually more than one set of values that would work for this. But what we're going to do is rewrite these equations until we can get an equation for x and an equation for y in terms of z. And you can do that any way that makes sense to you. So here's my approach. When I look at the first equation, I see that x is nearly isolated already because it doesn't have a coefficient. So I'm going to turn that into an x equals equation right away. All right, I've isolated x. I'm going to put that one on hold. It's not in terms of z, it's in terms of y. So now what I need to do is get y in terms of z, and then I can use substitution to finish that up. The second equation has both y and z in it, so I'm going to isolate y in that equation. I've got y in terms of z. Now I need x in terms of z, so I'm going to use this expression and plug it into my equation with x and y. Okay, if I just simplify this, then I will have x in terms of z. Let's change that 1 to 11/11ths so I can combine those things. And so my final answer for x is this. We write the answer like this. And there you got it. Finally, you will have some problems where you need to find the equation of a parabola, and the given information is 3 points on the parabola. 3 points is the minimum amount of information that could be given to you if they're just giving you random points on the parabola. We're going to make a system of 3 equations with 3 variables and solve it. That's why this is in Unit 11. Here's how we do it. Take the quadratic form of a parabola equation and plug in each of these points one at a time. Here's what I mean. If I focus on the first point, then x is -1 and y is 4. So I substitute those into the equation and I get 4 is equal to a times -1 squared plus b times -1 plus c. That's my first equation with 3 unknowns, so as you can see the unknowns are a, b, and c. Then plug in the second equation. X is 1, y is 6. And finally, using the third point, I've got 0 is equal to 3 squared a plus 3b plus c. So there's my system of equations with 3 unknowns. You can move it around any way you want to. Use your previous techniques to solve for a, b, and c. I'm not going to do that here. I'm just going to give you the solution because I want to show you how to write the final answer. So the solution turned out to be -1, 1, and 6. Those are the solutions for A, B, and C because it's standard to put them in alphabetical order. So rewrite your final equation. Remember, the goal was find the equation of a parabola. You can write it in quadratic form like this. So now that we know A is -1, we've got -x squared. And B is 1, so I have plus 1x. And c is 6, so the constant term is just 6. This is the final answer. So make sure you go a step beyond just finding A, B, and C. That should be all the information that you need to get going on the homework for 11.1.